Yes.
Mr. Deeds. I know. So, for mean value theorem to apply, it must be continuous and differentiable. So I look at this function right here. Is that continuous and differentiable from -2 to 1?
But isn't that Rolle's theorem also?
Rolle's theorem that points at the equal height. Does he have the equal height? In fact, Rolle's theorem is a special case. Because if they're equal height, what would be the average slope between the two? 0, right?
Oh, yeah.
If the average slope is 0, there must be some place between there where the slope is 0. So Rolle's theorem is a special case of MVT. So that's why I say Rolle's theorem is almost completely wasted time, because if you suddenly needed Rolle's theorem, you could call it MVT. And you need MVT. Okay. So does mean value theorem apply? Yes, it does apply. Why? Because between -2 and 1, the function f of x is continuous. And I'm going to cheat and write and differentiable. That's totally allowed. Okay. Now what? So it's continuous differential. The mean value theorem applies. What does it tell us? It tells us the average slope must exist somewhere between these 2 points. Must be this case. So the average slope would be, you remember how to find the average slope? The average derivative is equal to the final point, f at 1, minus f at -2, all divided by 1 minus -2. Right? It's the average slope. There's 2 points at the end, right? How we found velocity way back when we said average speed, right? Go back to the original function, just plug in the original function. So if I plug in the original function, I get 1 minus 4 over 3, so I get -1. Agreed? All right. So what do I know? I know somewhere between -2 and 1, there exists a derivative of -1. Now, everyone with me so far? That is the mean value theorem. We are done with it. That's all it says. I can prove to you now that somewhere between those 2 points is a derivative of -1. Done. That's it. That's all I can prove with mean value theorem. Now, what do the stupid instructions say that sometimes the essential makes you do? Yeah, find where it's -1. Well, if that's the question, why don't I just take the derivative to begin with? What am I doing this for? This is crazy talk. This is when you don't know what the function looks like, or I can't take derivatives mess. Right? So, do you understand the idea? Okay, so now we're going to go ahead and do what it says, because, again, Central does this all the time. It's like, keep these separated. These are 2 different piles. Should be. Okay? So, how would I find when the derivative happens to be -1? I would take the derivative. F prime of x equals 2x, right? Plug in -1, I get 2x. Where does it happen? -1/2. And where's that point going to appear? Somewhere between -2 and 1, which it does. Ta-da! Make sense? Okay. So the top part is this top part up here. Everything above this line, that's the mean value theorem. Everything below the line would be how you'd actually do it if they gave you f of x equals x squared and said, prove that the derivative is -1, somewhere between those 2 points. Well, duh, put it in, take the derivative, solve where it's -1. It's between those 2 points. That's the way you would do it for realsies. On the AP test, they're often going to give you something so ugly you can't do it. And then the 50-50 chance they'll do something just like this. And you're like, you're wasting my time. But okay, we'll do it both ways. Okay, good? Make sense? Everything good? Sense? Got it separated? Vanuelos? Got enough sleep last night, so you're good?
Yeah.
What's with the hood thing going on, man?
It's not here.
The assistant superintendent of schools is coming by, is doing room-to-room checks right now.
Wow.
Really?
Yes.
Why?
I don't know.
I'm in the game. Yeah.
Mr. Vanuelos, you're not nearly scary enough to be in a game. Not even close.
But
Not even close.